but key factors to consider when thinking about implementing these things. So we start with lots of types of waste you can use, and this is a wide range of variety. I guess the most common one is wood waste, and wood chips has been used as a biomass fuel in many applications for a number of years. The type of wood waste can also differ, but wood chips is the most common one. But we also use sawdust or saw shavings from sawmills, and or even so the bulky stuff coming out from forestry residues. With agricultural waste, again, there's a large range of different stuff that you can use. Here in Australia, well, we've seen a lot of use of bagasse in the sugar mill industry, and some really large projects have been implemented in the last few years. With animal farm waste, we've been also seeing a lot of activity in the meat processing sector, where they're using anaerobic lagoons to capture the biogas and using that for thermal processes. But there's also other options to use that sort of waste. Urban waste, mainly municipal solid waste and commercial industrial waste. There's a few applications within waste management processes that where they already have the logistics in place and they have access to all these materials. And normally what they do is they burn them in mass combustors to generate power, and then use the power for their own facilities. And within the food processing industry waste, there's again a number of different waste available. It could be in the form of wastewater or solid waste. One example, for example, in wineries is the use of grape malt, and we'll talk about a case study later on that they can burn in a biomass boiler. Abattoirs, again, I said that there's a lot of emphasis on biogas. So I guess the message here is that this is a lot of stuff that you can use, but it's also important to consider that it's not just the type of waste, it's also their properties that can have an impact on the way you use this fuel. So things like the heating value, just how much energy can I get out of a certain volume of this, moisture content and ash content, which can also have an impact on the heating value, and the design of the handling and the storage of the material. Chemical content is also important because there might be some substances that can be hazardous or might have negative impact on from an environmental point of view. The bulk density is also an important property because it will have an impact on the design of your storage facilities and so on. So as I said, it's not just the types of waste, but also the characteristics of each one. So what can I do with these things? And here we've got a sort of a map which shows you what are the types of waste and the different conversion technologies that are available to generate energy or other products. And then it's what do I have on site, what is my need, what is my requirement, where I can see an opportunity to use some of this waste. So I've put an example here. Suppose you've got a gas boiler, it's generating steam, which is required for your thermal processes, and there's some wastewater that I'm generating from my process, and suppose you can also have access to some food waste that is available from an external source. So really, it's about sort of linking these two things together and choosing a suitable conversion technology to use this material and achieve what I want. So in this case, suppose you can have an anaerobic digestion process where you can use the wastewater and the food waste co-digested in a digestion tank. It can generate biogas, which I can then feed into my gas boiler, and therefore be able to offset the natural gas that I'm using currently in this equipment, in this process. But also important to note is that there's also some other products, like in this case would be in the form of a digestate, which I also have to think about what to do with it, and some of that can be will need to be disposed in landfill, or it can be have some other alternative use. So in the case of digestate, for example, that's can be used as a fertilizer because of its nutrient content. So that's an example, a very simple example of what to do. And you can see that there's a number of different technologies available. So the question you might be thinking of, well, what if instead of using an anaerobic digestion process, I use a biomass boiler? Can I actually use a biomass boiler to process this sort of waste? Or how about a gasification process? So in the next slide, we'll see that there's also a number of factors that are important when selecting the technology. You can see that only a few of them are well proven and have been implemented with success in many different applications. Those are in the on the right hand side of this curve, which shows. Sorry, go back to the slide. So technologies such as anaerobic digestion or biomass boiler in the form of storage boilers or fluid isolate, or even co-firing in existing boilers. These are things that have been used for several years and with successful results. So if you were thinking about using a different technology such as, say for example, gasification, you can see that it's still in its early stages of development, and therefore the anticipated cost for a full-scale application might be pretty high. Even though we've seen a number of examples in Australia using gasification or pyrolysis, some of them are really sort of early commercial stages, or even pilot scales. So I guess when thinking about the potential to apply this opportunity for your processes or businesses, we'll probably focus on these type of things, on the technologies that are very well mature. And apart from the level of development, there's also a few other things to consider, which is also what is the scale of the application, and how that then suits with the technology that I'm going to use. So things like incineration, for example, of municipal solid waste, that's normally for large-scale applications, and where, as I mentioned before, companies in the waste management business. They have access to large amounts of waste, and they can generate large amounts of power from incinerating this material. So it's probably not suitable for a medium-sized, small-sized application because of the cost that is associated with that and all the logistics. But things like biomass boilers and anaerobic digestions are available for in small capacities and have been used in small-sized applications. Biogas engines are also available in small sizes, and cogeneration of using biogas to generate heat and power. There's also a few examples that we've observed. There's also the O&M cost, and particularly it's important to consider this when we look at storage and handling of materials, because it's much more, in the case of a biomass boiler, for example, it's much more labor intensive as opposed to a gas boiler that can run unattended. So it requires more attention. But there's also disposal costs that will need to be considered. If the ash that's been produced from the combustion process will need to be disposed. So there's a lot of things we need to think about. And the other I guess key aspect is how well do these technologies integrate with my existing infrastructure. And we'll talk about this in more detail later on. But yes, if you already have, for example, a coal fire boiler that you're using for the process, then maybe it makes sense that you can co-fire biomass with coal because you already have all the sort of facility and the infrastructure to do so. Where it could be more complicated if you sort of need to install a new biomass system from scratch. So that aspect is really important. So I guess today we